Okay, welcome, Roxy, Marina, and Marquette, and Sophia, and Jack, and Denise, and Jose and Liz. Hopefully the quiz went well, and even more importantly, hopefully your project went well. So let me jump right to the quiz. If you had 10 more seconds, you could have solved one more. Okay, well, do your best is all you can do. Remember, these are quizzes. They're not worth that many points. But hopefully there was enough time for most of you. So let's read it. So suppose that the weight of a medium-sized orange is uniformly distributed between 82 and 94 grams. You must show your work. Okay, so the first thing I recommend is actually just do a quick picture sketch. And never works great, but I'm going to try drawing a picture using the zoom tool. So let's see if it allows me. Okay, so we have a uniform distribution, and it is between 82 and 94. And we need to get the height of this rectangle. So do you remember how to get the height of the rectangle if you have a uniform distribution? And remember the way that works.
Use area equals base times height, and then put in 1 for the area and the difference between the two values for the base.
Good, good. So that's exactly what we're going to do is area equals base times height, and the area of the whole rectangle is always 1. So that means that we can solve for the height. Now, I'm just letting you know I'm using Zoom and Canvas combined. It doesn't work so well, so I'm going to clear this, but hopefully you can remember it. And now that we've got that, we can write down our area equals base times height. And 1 is the area. And the base was 94 minus 82. And the height is h. So 94 minus 82 is 12. So 12h equals 1. So if 12h equals 1, what does h equal to?
1 over 12.
Yeah, 1 over 12. Any questions on that piece? Okay, so now we need to say what's the probability that it'll be smaller than 90. So now I'm going to draw again. Hopefully it'll allow me to. So we have smaller than 90. So here's our picture, and now let me pop in the numbers. So again, we're going from 82, that's 90, and it goes up to 94. And then our height now is 1/12. Any questions on this picture? Okay, so for part A, that's what we need to find. And in terms of smaller than 90, if we want the probability of that, what do we have to calculate now that we can look at the rectangle?
The area of the blue.
Yeah, the area of the blue rectangle. So now, again, it may not look so great. So I'm going to, hopefully you can see this now. And I'm going to erase it and then go into it because Zoom is always weird with Canvas. So let's get rid of it. So if you remember, we want the, whoops. We want the area of that blue rectangle. So area equals base times height. I always like to start there because that just gets you going. It also gives you some points if you don't know what else to do. So area equals base times height because we have a uniform distribution. And the base was the smaller than 90. That went from 82 to 90, or 90 minus 82. The height was 1/12. And that is equal to, well, 90 minus 82 is 8 over 12. And you could leave it like that. So what we can say, I guess I should write down this part A. The probability of being smaller than 90 is 8/12. Okay, if you want to write it as a decimal, you can. It's not necessary. If you want to simplify the fraction, you can. That's not, I don't really care. What I care about is that you kind of demonstrating you understand how these probabilities work. Any questions on part A? Okay, so now we want part
B. Is it okay if we reduce the fraction?
Yeah, that's what I just said, is you could reduce it if you feel like it. You can turn it into decimal if you feel like it.
Also, I wrote it slightly differently. Does that matter?
Yeah, I mean, if you wrote 2/3, that's fine. That's the reduced fraction if you wanted to reduce fraction.
No, like I showed my work a little bit differently. Does it matter if you still have all the correct values and still have like,
as long as it's clear what you're doing, that's all I care
correct
about.
answer. Okay,
Yeah,
cool.
the important
Just
thing
making
is
sure.
your work is supposed to communicate your thought process. Does that make sense?
Yeah, I was just making sure that I wouldn't get marked down for doing it a different way.
No, it doesn't. No, it doesn't have to be exactly the same way. But here's the thing: even if you knew it was 8/12 and then you stuck it in a calculator, and let's say you just read it wrong, and you wrote 0.43, okay, which is not right, by the way. And then you didn't show your work, and all you have is 0.43. I can't give you points. Does that make sense? So
I mean, that wasn't what I was asking, but yeah.
So the main purpose of showing your work is if you get the answer wrong.
No, I did show my work. That wasn't that.
Yeah. So I'm saying it's good that you showed your work, and if you got the answer right, then that's great too. So everything's wonderful. That's what I'm trying to say. So don't stress about if your work doesn't look exactly the same as mine, because there's lots of ways of going about it. But there is only one correct, true answer in lots of different formats, but there's really only one correct answer. Okay, so let's look at B. What is the 76th percentile for medium-sized oranges? So I'm going to draw the picture again, so I think it helps to see the picture. So we want the 76th percentile. And if you want the 76th percentile, 76th percentile is more than half. So that means it's going to go farther than 50%, somewhere around there. Any questions on that? Okay, we still have, let's write it out, 1/12 for the height. And for these numbers, it went, remember, from 82. We don't know this number. That's the whole point. So I'm just going to call it X. But we do know the right end, and that is 94. And what we do know also is that the area of this red rectangle is 0.76. Any questions on that? Any questions? All right, so I can write B. I think this will still work. And again, I'm just going to write just blindly almost A area equals base height. Do I know the area? Do I know the area of the rectangle? What do you think?
0.76.
Yeah, it's 0.76 because that's given. That's what it means for the probability of being less than that value to be 0.76. Okay, that is equal to, what is the base? How do we write the base? So again, it's always the right minus the left. What's the right of this rectangle?
X.
X. And what's the left?
82.
82. Okay, and what's the height?
1/12.
Mm-hmm. And now we got to do a little bit of algebra. The good news is that it's the same algebra every time. Whenever you're doing a uniform distribution, you need to find the a percentile or a quartile. It's always exactly the same steps. So what do I have to do to get rid of the 1/12?
Multiply both sides by 12.
Yeah, so I multiply by 12. So I'm going to write that in. And when I do that, I get 70.76 times 12. I'm going to leave it like that because I'll do the arithmetic at the end. The 12s go away and you get x minus 82. I want x by itself, so what's the next step? How do I get rid of the minus 82?
Add 82 to both sides.
Yep, so plus 82 and plus 82. And what I get is 0.76 times 12 and then plus 82 equals x. Okay, and you probably don't want to do that arithmetic in your head, so I can copy that, pop it into Google, and you get 91.12. So the 76th percentile is 91.12. Any questions on question 1? Okay, I'm going to get rid of that rectangle because it's too hard to deal with. Okay, the next question is, suppose the time it takes a Tesla Model Y to charge a Tesla Model Y is uniformly distributed between 4 and 7 hours. Suppose that today it took Luz 6.9 hours to charge Luz's Tesla Model Y today. Use z-scores to determine whether 6.9 hours is an outlier. Show your work. All right, so we need z-scores. So what important numbers do we need when you need a z-score?
The mean and the standard deviation.
Yep. And I'm gonna write mean because it's too much of a pain to write mu, to do the mu thing, or maybe I'll write mu. It's kind of a pain to write in Greek, then I have to go to the equation editor and all that. So I'm just gonna write mu. What is the formula for mu? Do you remember? You're close, Jack, but it's not minus, it's plus. Because the average of two numbers, you add them and divide by 2. So it's 7 plus 4 over 2. And that is 5.5. 11 halves is 5.5. And then we have the standard deviation, right? SD for standard deviation. And that had a big formula, which was the square root of b minus a squared. B minus a is 7 minus 4 squared over 12. Which, by the way, 7 minus 4 is 3. 3 squared is 9. So that's the square root of 9 over 12. And let's pop that into quick calculator. 0.866. Any questions on getting the standard deviation? Any questions? Okay, now it says use z-scores to find out if 6.9 is an outlier. So who remembers the formula for z-scores? Yeah, you take the x value, which is 6.9, minus the mean, and the mean is 5.5, and you divide by the standard deviation, which is 0.866. I should write z equal. And you probably don't want to do that in your head, so I'm going to pop that in your calculator. And you get about 1.6 is good enough for us. How do you decide if a value is an outlier based on a z-score? What's important about the 1.6?
It's less than 3.
Less than 3 would be extreme outlier.
Yeah, less than 2.
Less than 2. So it's less than 2. So 6.9 is not an outlier. Any questions at all on this question or the whole quiz? Any questions? Okay, if there's no questions, I'm going to jump into the schedule. So are there any questions about anything else? And while you're thinking about it or typing, I want to mention a couple things. One is your project was due today. Hopefully you all got that and you turned it in. It takes me time to grade the project. Quizzes I can grade real fast. You know, it's a couple questions and it's a little half sentence that I write. Projects take me time. So if it takes me some days to grade your project, please be a little patient because the projects tend to be long. There's a lot of them. And, you know, I want to make sure that I don't rush through it because they're too important. So I will grade your projects in the next few days. I'm not a procrastinator. So, you know, by the end of the week, for sure, I'll have them graded. But I can't tell you, you know, it won't be tonight. That's for sure. Probably tomorrow and the next day will be grading days. Okay, that's my best guess. Okay, I can't tell you for sure. If not, then I'll finish it on Friday. Okay, I have kind of a busy Thursday. Teeth cleaning, dental work, good, happy dental work instead of sad. But that's going to take a little extra time that I didn't anticipate because I'm vaccinated, so I can comfortably go to the dentist. So just let you know that I'm going to do my best to grade your project, but I'm not going to rush through it because that's not fair for you all. The other thing is just a heads up. It's not that soon, but it's going to happen. What's happening a week from Thursday?
The exam.
Yeah, the exam. So a couple things. The main thing right now is to make sure that your computer can handle Proctorio. So that's the number one, is that you got to make sure that you have a computer that can do it. Again, you must have a webcam. You must have a webcam. Has to, work with Proctorio. Chrome. So if you don't have Chrome in your computer, make sure you install Chrome, because Proctorio wants Chrome as a browser. Doesn't cost anything. And if your computer doesn't work, what can you do? Do you remember what's available to everyone without a computer? I don't see y'all jumping in. Yeah, you can borrow it. You can borrow it from the library for the entire quarter, and it costs nothing, so it's free. So that's the good news. The bad news is it's a cheap computer, but it does work with Proctorio. So don't expect to do like your favorite gaming kind of stuff, because it'll be too slow for that. But it'll work great for the test. And it worked great for this class. Just let you know, because the Chromebook, the cheap Chromebook, but it works. Okay, so that's important. So make sure that in your schedule, you plan some hours, not just to take the test, but to practice. Okay, if you want to pass this class, you need to practice many problems. And my feeling is the best kind of problems to practice are the quiz problems. Redo them. Those are always shown in the webinars. You can always grab those again. You could do the homework problems also. But the quiz problems are more realistic because they're in Canvas. You're going to be writing things out and showing your work, whereas the regular assignment ones, you don't have to show work. So for the exam, you do have to show work. So that's why the quiz is the best practice for the exam. Okay, and the exam questions they won't be the same as the quiz questions, but there'll be a lot of them in the same feel. So any questions about the exam or about anything else that's going on in the class? Any questions? Okay, if there's no questions, what I'm going to do is I'm going to ask you a question. Who remembers, and hopefully all of you do because it was part of your project, who remembers what the empirical rule is?
For the normal distribution, saying that like certain percentages are within a standard deviation.
Right, 68% within one standard deviation. Who remembers two standard deviations? Which turns out to be the most important of the three. Yeah, 95% within two standard deviations. And the 95% turns out to be really important. In 2 weeks, we're going to spend some time on that. Right now, just trust me that the 95% is the biggie. So, and also 3 standard deviations. Remember, if you're 3 standard deviations away, you're an extreme outlier. That means it's very unlikely. Okay, it's not 97.5. You're close, though. Might have been a typo. So let me show you the picture. It's 99.7. So here is the picture of the empirical rule. So the empirical rule says that if you have a normal distribution, then if you're within 1 standard deviation of the mean, so in other words, between -1 and 1, that means that 68% of the data will have a z-score between -1 and 1. And to make life easier, instead of even talking about z-score, we're just going to let z be the standard normal distribution. What a z-score does is it makes the mean 0 and the standard deviation 1, if you think about it. Okay, so it does a little transformation and turns it into a 0 for the mean and a 1 for the standard deviation. So it says that if z is between -1 and 1, then that fits 68% of the data. And if z is between -2 and 2, that fits 95% of the data. Okay, approximately, the nearest whole number or so. And if z is between -3 and 3, it's almost all of the data. It's 99.7% of the data. Any questions on the big empirical rule? Okay, so this is for a normal distribution. Do you think the normal distribution is easier or harder than the uniform distribution?
Harder?
Yeah, it's harder. Why is it harder?
Because it's like not a straight line.
Yeah, but with the uniform distribution, what's the big formula you get to use that always works?
Area.
Hopefully, yeah. And what was the area?
1.
Well, the area is 1 for any distribution. What was
Oh.
the formula? So it's a formula for area for a uniform distribution.
Oh,
yeah,
okay.
BH. So the area is the base times the height. And that's easy. You just multiply those two numbers. Okay, now for a normal distribution, I gave you these numbers, or the empirical rule gives you those numbers. But if you wanted like between 0 and 0.3, and you don't have these numbers, do you know how to find this area? Because you can't just use base times height anymore, can you? Because it's not a rectangle. Or maybe, yeah, not a chance. And if it's between 0 and 1.5, then it's the area of this thing, and it curves around here and goes, it's not even close to a rectangle. So the answer is good luck. Okay. Also, who remembers if you have the uniform distribution, what's the equation of the distribution? It's very simple. That's a hint. What's the equation of the curve that shows the distribution? For normal, the curve is this bell-shaped looking thing. For a uniform, it's flat. What's the equation of a horizontal line? You remember, it's very simple.
The height?
Yeah, but in particular, it's y equals the height.
Yeah.
All right. Do you know what the equation is for this normal distribution? Good. Silence is what I expected. So here's the equation. It is 1 over the square root of 2 pi e to the negative x squared all over 2. Okay. Do you know why I said it really fast? Any guesses?
We don't need to know.
You don't need to know it. You are never going to use it. Got it? Okay. You're not going to use that equation. You're not going to find the area. Do you think there are ways of finding the area? Do you think I know how to find the area?
Yeah.
Or at least approximate it to as many decimal places as I want? Yeah, the answer is yes. Yeah, I'm the professor, so I know how to do it. You will never learn it in this class. Most of you will never learn it, period, because it involves some very intense mathematics. So the good news is you don't have to do that. But I do want you to understand the empirical rule and be able to use it, and also understand probability. Any questions on what my expectations are? Okay, so now let's do some examples. So here's the example. So we're going to say, suppose x follows a standard normal distribution. Use the empirical rule for the following. I want to mention something, and this is important. Here's something you are responsible for. If it follows a standard normal distribution and it's z, then I'm going to write z. Do you remember the symbol we used last time to talk about follows a distribution? The hint is it's on your keyboard, and most of you didn't know the name for it. Yeah, that was a tilde. Okay, so z tilde. Okay, last time when we had a uniform distribution, we'd write x tilde u. but this time I'm not going to write U. What do you think I'm going to write?
N.
N. We're going to N, and N stands for normal. Got it? Okay. And then parenthesis, and then the way we write it is we write the mean, comma, the standard deviation. The mean is 0. And the standard deviation is 1 for the standard normal distribution. Any questions? Any questions on this? Okay. I just want to let you know on, especially on exam 2, it turns out, and you'll understand why next week. On exam 2, I will ask you to write down the distribution. And if I ask you to write down the distribution, this is what I intend. I intend a tilde. I intend an N or a U. I intend the mean and the standard deviation if it's normal, or the left and right if it's uniform. So if I say, or when I say, write down the distribution, that's what I mean. Any questions on that? Okay, now a nice, easy question. Part A is going to be really easy and it gets harder from there. Is find the probability that Z is between -1 and 1. So what is that probability? The hope is you can all just jump in and say it without doing any work. Good, good. So I'm going to write P for probability, -1 less than Z less than 1 is equal to, usually when you write probabilities, you tend to write decimals and not percents. Okay, and one of the main reasons for that is if you have to do any math and stick it in a calculator, percents don't work. You need to use decimals. What's the Z for? That's a good question. Let me write 0.68 first. So notice that we said Z follows a standard normal distribution. So in the instructions, I labeled the variable as Z. Does that make sense? Is that clear or is that still confusing? Yeah, so the variable Z, okay, and by the way, in a little bit, and I think the last of this group of questions, you can understand why we use letter Z. Okay, not for zebra, by the way, but we will understand why we use the letter Z and it'll make sense. Any questions at all on this part A? Any questions? Okay, so that is just given, basically. That's part of the empirical rule. Okay, now it's time to get a lot more difficult. Okay, because this one, you just write the answer, you're finished, you don't have to do anything. So now we're gonna actually do stuff. I don't mean impossible or intense, but more than just look at it and write down the answer. Okay, so part B. Find the probability that Z is less than 3. Any questions on the question?
Can you make the image any bigger?
Yeah, the only problem with that is if I make it bigger, then I'm not gonna be able to write much below it and you'll be able to see both. Is that
I
good?
can't read the numbers on that. I'm sorry.
Yeah, how is that? I just
That's
made
my problem.
I made it a little bigger. I will tell you that the numbers are just in order. 0, 1, 2, 3, 4 down here.
No, like I can't really read the percentages on top. That
Those percentages never change. That's the empirical rule. 68, 95, 99.7. In fact, sometimes they call this, sometimes they don't call this the empirical rule. Sometimes they call this the 68, 99, 99, 95, 99.7 rule. So I've actually read some books that call that's what they call the rule. Does that make sense?
Yeah.
So those numbers are always going to be those numbers when you're talking about the normal distribution for the standard normal. Does that make sense? So that'll never change. So this is just a copy of the same picture over and over and over again. That's the good news. So you can put in your notes what the numbers are if you want, because they're not going to change. Sound fair?
Yeah, sure. Sorry, my eyesight's just terrible.
No. I understand. No, it's small. Okay. And by the way, the y-axis numbers, don't worry about. You don't need to know them. Okay. So if you can't read what it says on the left numbers, who cares? Got it? But in the bottom, this is just a 0 for the mean, and then -1, 1, -2, 2, -3, 3, -4, 4. That's how every picture is the same picture. I just copied and pasted the same picture. So maybe put on a piece of paper and just write it down on a piece of paper so you've got it in front of you, because we're going to be using it. Okay, so we want to say z is less than 3. So I'm going to do a little drawing and going to draw the z is less than 3 part, if it lets me. I think it will. So I'm just going to kind of like pretend I'm shading in-ish. And then this less than -3 also includes, I'm just going to put a little red over there. Any questions on that? Any questions? All right, so I need the area of this. I need the area to the left of 3. And the problem is none of these numbers gives you the area to the left of 3. Okay, you can't just do it with one of these numbers by itself without doing anything. But let's see what we do have. How about we could say is that if you want to go from -3 to 3, we know the answer. Do you agree? What's the answer? If I asked instead of less than 3, what if I said -3 to 3? What would the probability be? Yeah, that would be 0.997. So here's the key. And this is something that you're allowed to do with probability. And that is, you can say that the probability that z is less than 3 is equal to the probability that z is between -3 and 3 plus the probability that z is less than -3. Any questions on that idea? Okay. So the idea here is I took something I don't know how to do, turned it into something that still may not know how to do, but at least we know part of it. So we can say that is equal to, well, the first term, okay, as Marquette said, is 0.997. Okay, that was our whole point. Any questions on that? Plus. Okay, so now we got to think about what about z is less than -3? So we know that between -3 and 3 is 0.997. So I like to put it in words. Inside is 0.997. If inside is 0.997, how do you get outside? Right, so if all the, you subtract from 1. That's the rule of complements. Okay, so we know that the outside is going to be 1 minus 0.997. The problem is we don't want the whole outside. We just want the left. We don't want the right. Okay, so if you wanted only the left and someone gave you both the left and right, exactly, you divide by 2. So what I can write is 1/2 times 1 minus 0.997. 997. Any questions on that? So you probably agree there's a lot harder than part A. But not impossible. You just have to break it up and realize you got symmetry, which means the left and right are the same. So if you just want the left and you have both, you divide by 2. And we also have the rule of complements, which means that if you have the inside, then the outside's 1 minus that. Okay, and then the rest is, I don't know, it's just busy work. We can pop in the calculator if you want. So 0.997, and then plus 1 over 2 times 1 minus 0.997, and you get 0.9985 is what Google gives me. Any questions? Any questions on this process? Okay, notice we're using some things that we learned about last time. Okay, even though we don't have rectangles, you can't do areas rectangles like we did before, but we're using the fact that the area under the curve is the probability. That's the definition of probability. Okay, and then once we know that, we can use the things we know about area, like the whole area is 1, because you have a 100% chance of being somewhere. That's always true, right? Okay, so the area of the whole thing is 1. So the rule of complements say that if you want to say what's the area of it, what's the area that's on the other side, that's going to be, or the outside, that's going to be 1 minus the inside. Okay, and then we're using the symmetry of the normal distribution. And that says the left and right are the same. So if you know the left and right combined, you divide by 2 to get just the left. So I want to stop. I want to make sure, is there anybody confused about what just happened?
I was so confused.
You're so confused? So what are you, which part are you confused about?
Sorry, I had to answer a phone call from my dentist right in the middle of that, so I missed.
Okay, that's a whole different problem. Yeah, and that happens. Coincidentally, you know, I got a call from my dentist about an hour before this lecture, actually.
Oh yeah, I'm getting a root canal tomorrow. That was what the call was about. So.
Oh no, that's a lot worse. I'm getting a teeth cleaning.
Congratulations. Are there going to be another example?
What's that? Oh yeah, no, we're doing more
examples. See another example.
We're gonna do more examples. But what I want you to do with the other examples, I'm gonna let you try first, and then I'm gonna do it. Because I think it's very important for you to try without watching me do it. Okay, it doesn't mean that you're not gonna see me do it. It just means I want you to try first. Okay, so it doesn't mean it's a good time to take a break either, because I want you to try. So it's not gonna be exactly the same as this one, but it's gonna have some of the same ideas, a lot of the same ideas. Okay, it's not gonna be 0.9985 when we're done. Any questions so far? Any other questions, specific questions about this one? Yeah, because this is, oh yeah, no, we're doing another one. I mean, it's not gonna be exactly the same, but it'll be like this one. Okay, I promise. All right, so let me, I'm gonna erase Scribble, because if I scroll, the Scribble does all kinds of weird things. Oops. I always do that. There we go. Okay, so here's the next example. The next example, again, it's not exactly the same as, it's not exactly the same as one we just did. But it's got some of the same ideas. Let's see if you can find the probability that z is between -1 and 2. And just for now, I'll make it a little bigger, but it's the same picture. So find the probability that z is between -1 and 2. And I want to give you a few minutes to do it. Doesn't take more than a couple minutes if you know how to do it. And if you don't know how to do it, it'll take you forever. And that's why I'll get, in a few minutes, I'll actually show you how to do it if you got stuck. And if you have a specific question, put it in the chat box and I can I can answer it. But I want to give you a try. So find the probability that z is between -1 and 2. And it's, again, has some of the similar reasoning. It's not exactly the same though. Different geometry. So give it a shot. And I did some shading for you, and very specifically to give you a hint. Okay, give you another minute. Because like I said, if you know how to do it, it's really quick. And if you don't, then you'll sit there. Okay, so we got one possibility, and we'll see if that's right. Okay, if you do 1/2 times 0.68 plus 0.95, I want to let you know, Jack, you get a number bigger than 1. Can you ever have more than 100% chance of something happening? So it's really important to know when to raise your red flag. And if you ever get a number bigger than 1, worry for a probability, because you can't have over 100% chance. So it can't be 1/2 times 0.68 plus 0.95. because of that bigger than 1 red flag. Okay, so we got a couple choices. All right, let me try. Okay, so the idea here, we do something very similar to what was just done. And what we can say is that we can look at the probability between -1 and 1 plus the probability between 1 and 2. So we break it up into these two pieces. And that's why I drew it this way as a hint. So we can do those two pieces. Any question on the breaking up into two pieces? Okay, so then, yeah, that's what I was worried about. I'm going to have to erase what I put in, but hopefully you got that annotation. All right, so we could say that the probability that z is between -1 and 1, -1 and 2, sorry, is equal to the probability that z is between -1 and 1 plus the probability that z is between 1 and 2. Any questions on that? And that's coming from my drawing that I did, my shading that I had a while ago. Any question on that so far? Okay, so that is equal to, well, between -1 and 1, that was part A, right? 0.68. Okay, we already did that one. Now we got to go between 1 and 2. So if you want to go between 1 and 2, well, we know between -2 and 2 that is 95% or 0.95. We know between -1 and 1, that's 68%. So if we take away this middle part between -1 and 1 from the -2 to 2, you get these two pieces. Any questions on that? Now, we don't want both the pieces, we want one of them. So just like in the last example, you take a half. So we're going to go 1 over 2, and then we're going to take away the -1 to 1 from the -2 to 2, or in other words, 0.95, here, 0.95 minus 0.68. Any questions at all on that idea? And then it's just stick it in the calculator. So I'll just pop in the calculator. And it gives me, I think I need to go, let me go 0.5. There we go. And it gives me 0.815. Okay. Which actually our first try, the first person who put in got 0.815, which is great. Okay, but the others didn't. So 0.815 is the answer. Any questions on part C? Any questions? Okay. Let's do part D. Find the value of z such that there's a 2.5% probability of being greater than this value z. I'm going to make it a little bigger because it sounded like you guys wanted it bigger. So we want a 2.5% probability of being greater than that value z. So first thing, I have a question for you. If you have a 2.5% chance of being bigger than a number, is that number positive or negative on this curve? Is it far left or far right? What do you think? If there's 2.5% chance of being greater, are you on the left or the right? Not both, you're on the right. Okay, so think about this way. If 2.5% of the people are taller than you, are you tall or short? You're tall. Okay, you're on the high side. You're not on the low side. Does that make sense? So it's not both, right? A little short person is not going to have 2.5% above them. They're going to have a huge percent above them. So that's the first thing. Is the second is this time we're given the probability. So we're given 2.5% above some number. Okay, I'm not going to give away too much, so I'm not going to write where the number is, but it's somewhere. So that's going to be 2.5%. I should never draw it. It's so hard to draw numbers. I should have typed it as text. Okay, 2.5%. All right, well, now we kind of do what we did before. And we use reasoning. All right, there's 2.5% to the right. Any questions on that? Okay, well, with the empirical rule, we don't understand right. We understand outsides and insides. So the right is only the right-hand side of the outside. So how much is outside? If 2.5 is on the right, and we want to do right and left combined, what do you get? We've done the same reasoning before. So, yeah, so if 2.5% is to the right, then twice that is on the outside. Twice 2.5% is 5%. Okay, so how much is on the inside? If 5% is on the outside, how much is on the inside? If 5% is outside, how much is inside? It's not a trick question. Yeah, 95%. That's important. Where have we seen 95%? Right? The hint is it's in the picture. So what do we know? What's Z? So what is Z? So again, we have 95%. There's that big old 95% right there. I know it's small, hard to read, but it does say 95%. So what do we know Z is? Very easy. I know it's little, but if you took some notes and you wrote it big enough. Comes from the empirical rule. So what does the empirical rule say about 95% of the data? And the picture too, if you can see it. Yeah, 2. Okay, it's not -2 because we already decided it's got to be positive. So that means it must be 2. And that's it. It's one of these really easy if you know what to do. And if you don't, you have no chance. Any questions on this idea? Oops, I got it. All right, let's see if you can find the 16th percentile. I want you to try one. Let's see if you can find the 16th percentile. And that's asking for what value of z is the 16th percentile. Shouldn't take more than a minute, actually, if you understood what I just did. The hint is it's very similar. Last time you asked for another one like it, well, here's another one like what we just did. It's not the same, but it's very like it. So you can put in the chat box when you've got the 16th percentile figure out. I'm going to have one more question I want to put in there. So what is the 16th percentile? It's pretty easy if you know what to do. And it's very similar. Last time we had 2.5%, now we have 16% below it instead of above. That's a hint. Okay, you did two of the steps correctly, but you need to do the last step. So asking for the 16th percentile is asking for a z, not a probability. So 68% comes in there, but it's not the answer. But it's definitely one of the main steps. So you definitely got part of it. But you just got to do the last step. So what is z? Just like last time, when we found when 2.5% was above, z was equal to 2. So it's not a percent, it's a number. So what is the 16th percentile? Very easy. Hint is very easy to type. Or pretty easy, at least. I don't see you all jumping in. Maybe I'll walk you through a couple steps. So we know that 0.16 of the area, then I'll write it as 16% of the area is to the left of this number. All right, well, the left we've seen before isn't enough. You need to get the left and the right. So how much is on the left and the right? If 16% is on the left, how much is to the left and the right combined? Not supposed to be too hard. So if there's 16% on the left, how much is on the left and the right, kind of on the symmetric picture? Yeah, 32%. Okay, 16 times 2 is 32. So 32 is outside. So how much is inside? If 30%, 32% is outside, how much is inside? Yeah, so 68% is inside. So same as what we did last time, different numbers, but same idea. So now if 68% is inside, then what is the value of Z? And remember, yeah, it's -1 because 16% is to the left of this number. That means the number must be small, right? If you're only 16th percentile. Thus, Z is equal to -1, and that's it. Any questions on that? Okay, I have a quick question for you. Quick and easy. Find the Z-score with this normal distribution, standard normal curve, if the value of Z is 2.3. So let me pop that picture in again. So we have the value of Z is 2.3. What is the Z-score?
You mean X? X is 2.3?
No, Z is 2.3 because this is a standard normal distribution.
Ah, right.
So what's the Z-score when Z is 2.3 for the standard normal distribution? And the hint is it's really easy. And if you don't see the easiness of it, then you won't get it. What's the formula for Z-score? How do you get Z-score? We've already done it today once in the quiz. Who remembers the formula for Z-score? Yeah, so it's X minus X bar over S. So now our value is 2.3. What's the mean for a standard normal distribution? By definition. What's the mean of a standard normal distribution? Yeah, the mean is 0. And then divided by, what's the standard deviation for a standard normal distribution? So what's the standard deviation for a standard normal distribution? It's what I said at the beginning of this kind of set of exercises. Do you remember? I'll pop it up because it was written there. What's the standard deviation for a standard normal distribution? It's 1. Z tilde 0, 1. So that means we divide by 1. You shouldn't need a calculator. What's 2.3 minus 0 divided by 1? 2.3. So I want to let you know the reason, because someone asked at the very beginning of this, why don't we use the letter X? Why are we using Z? Here's the reason. Because it is the Z-score. When you have a mean of 0 and standard deviation 1, then that value, whatever you've got on the graph, is its own Z-score. Isn't that beautiful? Okay, it's 5:05. Let's take a 5-minute break because I like to do that if we can. And we'll come back at 5:10 and then do things that aren't standard. So I'm actually going to stop the share. Okay, it's 5:10. Welcome back. And let's continue on and do more examples. Okay, so I just want to let you know there's not a lot of concepts here. It's really just practicing lots of examples. But what we're going to do now is totally different in terms of process from what we just did. So let's go ahead and I'm going to share my desktop so you can see more problems. Okay, so now this example is the following. Suppose that X follows a normal distribution with mean 114 and standard deviation 23. Okay, why do you think I used X and not Z? Why did I change the letter on you?
Because it's not normal, not a normal distribution now.
Actually, it is normal. See the word normal? It's not about the normal, but about, yeah, it's not a Z-score. The mean isn't 0 with the standard deviation 1. Does that make sense? It's still normal. It's still bell-shaped, but it has a different mean and standard deviation. Does that make sense? Okay, so that's just a note. We use X when you have a general normal distribution. We use Z when you have the standard normal distribution with mean 0, standard deviation 1. Okay, now what I want you to do, see if you can put in the chat box. If I ask you, write down the distribution, what do you write? Symbols. No words. What do you write? The hint is you can type everything into your chat box. So if I say write down the distribution, what am I asking you to do? Give you a minute. Again, if you know what to do, it's just typing and it's not that long. So if I say write down the distribution. Here's a hint. There's a symbol that has to be in there that's on your keyboard. So what do you write? I don't see y'all jumping in. Okay, very close, except not Z. What letter do we use? For this example. Yeah, X. So X tilde N 114, comma 23. Any questions at all? Any questions at all on writing down the distribution? Okay, so now part A is find the probability that X is between 100 and 120. Okay, and just a note, if I just asked you to do this and you didn't have any technology, what would you do? Don't see y'all jumping in. Okay, let me tell you what you'd probably do is cry because you can't. Okay, cry, maybe be angry. Okay, but I'm not going to do that. We're going to use technology. So we want X between 100 and 120. Okay. Let me write some stuff down. All right, so what I'm gonna do is I'm gonna go to the calculator. And now you're not supposed to cry. Now you're supposed to tell me what to do. So which calculator do you think we need? I tried to make it obvious when I created these. You can type in the number or the words, I don't care. Yeah, number 8, normal probability, because we have a normal distribution and we want a probability for a normal curve. So I click number 8. And it asks me, what is the low? What do you think the low is here? If it helps, you can go back to the problem. What's the low? Yeah, low is 100. So I type 100. What's the high? The hint is it's not hard. Let me go back to it. So what's the high?
120.
120. What's the mean? If you want to go back to it, what's the mean? It's not a trick question. Yeah, 114. What's the standard deviation?
What, 23?
That's 23. Okay, and we're asked to find the probability. P stands for probability. So that one we leave blank, okay? Because it says fill in all the values except one below and hit calculate. Then the last value will be given to you. So hit calculate. And there's your answer, about 0.33. Any questions on this? Was this hard or was this easy? What do you think? Okay, easy for now. I don't think it gets much harder, actually. Into a few little details. So answer is 0.33. All right, let's look at the next one. What's the probability that X is greater than 200? So what is the probability that X is greater than 200? What's the low? What's the boundary of all numbers that are greater than 200? The hint is it's very easy. Not a trick question. So what's the boundary of all numbers that are greater than 200?
200?
What's that?
200?
Yeah, 200. Oops, here. There we go. What's the highest number greater than 200? That's a tougher one. What do you think? Any thoughts? What's the highest number greater than 200? Yeah, it's infinity. Okay. One problem is computers can't handle infinity. I don't know if you know that, but that's not a number to in a computer. So we need to what I call trick the computer. So we're not going to write infinity because that's not a number. We're going to write down a very large number. So here is what my recommendation is that will always work, is you look at the numbers that we have here and how many digits is the biggest number have? What do you see? How many digits does the biggest number have of the numbers here?
3.
3. Add 2 more. So that's 5 digits and just put 5 nines. And what that will do is it will make it such a giant number. So let me show you the picture again. Let's make it big picture. There we go. So again, we have a normal curve. And this is like 3 standard deviations. If you go 100 standard deviations away, there's so little to the right of you that there's no problem. Does that make sense? That it's good enough. It's to as many decimal places as you could dream of. Okay, hundreds of decimal places. So the good news is if you just take the number of digits, add 2, put that many nines in, then that's how you trick the computer into infinity. What do I do for p equal? It's probably not 0.3315, etc. What do I do for p equal? Any thoughts? So what do I do for that? Any ideas? I don't see y'all jumping in. Okay, the thing is it's what we want. If it's what we want, then you leave it blank and then the computer will fill it in when you hit calculate. But you have to leave one blank and you leave the one blank that you want the computer to solve for you. So I hit calculate and there we go. Very small. In fact, I'll even copy and paste. So answer 0.00000923. Any questions at all on that? Okay, and you shouldn't be too surprised. 200 is a lot bigger than 114, seeing that standard deviation is 23. One standard deviation above 114 is 137. You're not even close to 200. So that's why it's such a small probability. All right, find the probability that x is less than 90. What I want you to do and just to make it easy for you, I'll put it in the chat box, a calculator. Let's see if you can find it. So find the probability that x is less than 90. Give it a try. Shouldn't take more than a minute or so. Similar to part B, but it's less than instead of greater than. And give you a minute. And to make it fast, I put in the chat box the link to the calculator we're using. Again, pop in the chat box when you've got it, or if you need help, I can help you. I don't see y'all jumping in. It shouldn't take long. Less than 90. Anybody get stuck? Okay, let's check it out. 1484 is, or 0.1484 is what you got. So let's give it a shot. So less than 90. What's the low of all numbers less than 90?
0.
-1 is less than 0. So what's the low? You can go lower than 0. And the hint is it's similar to what we just did. Okay, the low is negative infinity. And again, you trick the calculator with a -5 nines. Oops, sorry, I just put it in the chat box instead. Let's pop it in here. -1, 2, 3, 4, 5. And the high is what? That should be easy. It's a high. What's the right boundary of numbers less than 90? It's supposed to be easy. I don't see y'all jumping in. 90. Okay. Anything bigger than 90 is not a boundary of less than 90. Same mean, same standard deviation. I erase the P and hit calculate. And you get 0.1484. Okay. Which actually Roxy got.
Was that not what I got? That was what I got.
But I just
So
wanted
wait,
to.
Can you, technically,
Huh?
can I use 0? Because I got the right answer using 0.
Okay, so you got it to 4 decimals. How about to 12 decimals? I bet you got something slightly different.
But how often am I going to use 12 decimals?
Yeah, so the idea is you got lucky.
Never. Cool.
All right, so here's the deal. You got lucky, okay? If you always use 0, then sometimes you'll get unlucky. If
But
you
how
always
often?
add 2 more digits and put all 9s in, then it'll always work. Does that make sense?
But how often won't it work?
I'd say about 10% of the time. Do you want to take that? You want to take that chance on the exam?
Honestly, at this point, what do I have to lose, right?
You have to lose points, and it's the putting a bunch of 9s in is easy. It's easy to type. -9. You just hit the 9 a bunch of times. Okay, so it also helps you understand what's going on. Okay, we will get to 0 in the next example, though. Okay, I think I'm going to skip D for time reasons. How about find the IQR? Do you remember what the IQR means? Who remembers IQR? Yeah, it's Q1 to Q3. Actually, it's Q3 minus Q1. It's Q3 minus Q1. And what is Q? So what is Q1? Let's go Q3. What does Q3 mean? '75th percentile. Okay, so that means 75% of the data or the area is to the left of some value. So 0.75. What is 0.75? Is it the low, the high, the mean, the standard deviation, or the p equal? What's 0.75? Where does it go in the calculator? Okay, it's not the high. It's not the high. It's not a value of x. 0.75 is not a value of x. It's not the high. It's the p. 0.75 is a probability because it's the area. Area is a probability. 0.75. Okay. The low, since we're going to the left of, is still negative infinity or negative bunch of nines. The high is what we want. So I'm going to leave that blank and hit calculate. And you get a, I'm going to use whole numbers, 130. That's Q3. And then I go minus. If I want Q1, what changes? What changes if I want Q1 instead of Q3? Yeah, the P is 0.25. And the high is what we want, so I leave it blank. And we get about 98. So 130 minus 98, which is 32. Any questions on that? Okay, let's do F, and then we'll move to the application. So find the middle 84% of the data is between what two values? So the idea is in the empirical row problem, we had to do that thinking. So let's write down the reasoning. If 84% is in between, how much is to the left? Okay, or how if 84% is inside, how much is outside? Let's do it that way first. If 84% is inside, how much is outside? How much is outside? If 84% is inside. Yeah, 16% is outside. Okay. If 16% is outside, how much is to the left? Because outside is left and right. So if 16% is on left and right, how much is the left? And it's kind of what we did in the first examples. Yeah, 8% is to the left. So now I'm ready to answer the question. 8% is to the left. Where does that go? Low, high, mean, standard deviation, or P equal? Yeah, P equals 0.08. And it's left, so low is negative 9999. As far left as you go, we want the high. And I get about 82. So between 82 and now we want the right. Well, if 8% is on the right, if 8% is on the left, 8% is also on the right. But if we want the right, then it's the low that we don't know, and the high is negative infinity, is positive infinity, or a bunch of nines. And I calculate, and I get 146. Any questions on this example? Okay, now for an application. Okay, so suppose that the time until you or your wife, if you're male, will give birth is normally distributed with mean 140 days and standard deviation 7 days. Okay. By the way, if the mean is 140 days, what do you call that? What do you tell people? How do you use that 140 days? You hear this all the time when people are pregnant. What does that mean that the mean is 140 days? What part of it? There's a conversation that always happens when someone's pregnant. They got that big belly, and what does someone ask you? Yeah, months of long pregnancy, not quite. It's the opposite, actually. It's when are you expecting? Months of long pregnancy is when you conceived. And this is not about when you conceived. This is about when you're going to have the baby. Does that make sense? Because giving birth is not conceiving. I think you all understand that. Okay, so 140 days is actually technically the expected value. Okay, which we did in a different chapter, but you can just trust me, it is. And it turns out the standard deviation used to be 7 days. Things have changed. Do you know why things have changed? We have any people in medical or want to be in medical? Anyone know why things have changed? It's not a math question. I don't see y'all jumping in. Okay, it's because of C-sections. So in the old days, it really was standard deviation of 7 in terms of how long before you gave birth. But now with C-sections, that's compressed because they pull the baby out if it's been too long. So we're going to pretend it's a natural birth. No C-sections allowed. Sound good? Okay, so the first thing is, how do I write the distribution? See if you can put it in the chat box. If I say, write down the distribution, what do you write? So pop in the chat box what the distribution is. Write down the distribution. We've done this before on the other examples. Good, good. So we have X tilde N 140, comma 7. And by the way, for natural births, it really is a normal distribution. Okay, and the reason is too complicated for me to explain. And I don't understand all of it because there's some medical pieces of it, and I'm not a doctor. Okay, at least not that kind. And but I know the stats of it, so I know why it actually works. But you can trust me, it is normally distributed. Okay, the 140 just means a day, that means 140 is how long, you expect. Okay, so now part A. Your boss just scheduled you or your wife for a business trip to China. You or your wife leave today, right now. Okay, and you're going to return in 135 days. Find the probability that your baby will be born in China. So we want the probability of what? If the baby's born in China, what do you know about X? So if the baby's born in China, what do you know about X?
It's below 140.
It's below what?
140.
Not 140. Read the question. Read part A. That's a hint. Yeah, it's below 135, right? Because at day 136, you're back in America. Okay, so we're going to have below 135 and can't be less than 0. So 0 less than X less than 135. So now we just go to the calculator. We have the low is 0. We have the high is 135. We have the mean was 140. And the standard deviation was 7. Any questions on that? P is what we want. We want a probability. And hit calculate. About 24% chance. By the way, are you okay with that? If you were pregnant? Okay, or if your wife was pregnant and you had to, say goodbye to her as she goes to China. We'd be okay if there was a 24% chance that the baby's gonna be born in China. Yeah, hopefully not, by the way. Yeah, it's not a good thing. You want to have the baby born at home. Okay, I mean in the hospital near home, but not in China. Okay, so that'd be bad. So first thing is we got 0.24. So you're not okay. So you decide that this is too risky and want to negotiate with the boss to ensure that there's no more than a 1% chance. Okay, you don't want to lose your job, so you want to be able to negotiate. You want no more than a 1% chance that the baby's born in China. Okay, what day should you ask to be the return date? Any questions on that idea? So what changes here? What changes? What do we know this time? If we want no more than a 1% chance of the baby born in China. Yeah, this time P. And what is P? .01, because 1% is 0.01. What don't we know? The low, the high, the mean, or the standard deviation? What is the one we don't know? Because that's the one we need to erase. Yeah, we don't know the high because the high is a return date. And I hit calculate. Okay, now if we wanted at most 1%, then we should always round down. So 123. So ask to return after 123 days. Any questions on A and B? Okay, now for C. All right. So now it's been 138 days. The baby still has not been born. Okay, you're back from China. That's the good news. Okay, but if you've ever had a baby, you get anxious around that time, right? Okay, you're 2 days from your due date. Find the probability the baby will be born within the next 24 hours. Okay. Any ideas on how to do this? We want a probability, so I'm going to write P. Any thoughts? Give you a minute to think about it. Okay, so what's new here is that we have information. And the information is the baby hasn't been born in the first 138 days. When you have information and now you want to find a probability, that's a given problem. Okay, and to be born within the next 24 hours, that means X is between 138 and 139. And we're given that it wasn't born in the first 138 days. So given, oops, I forgot the X. We're given that X is greater than 138. Because we already know the baby's not born. Any questions on that? Okay, now you got to remember from chapter 3, the given rule. And that is when you want the probability of A given B, that's the probability of A and B divided by the probability of B. Okay, if I say that the baby be born between day one, if one of the probability of the baby will be born between day 138 and 139, and the baby will be born later than 138. What does this greater than 138 tell you for the and? Any thoughts? So let me give you an example, one that might be easier to get your head on. I'm going to tell you that I am between 50 and 60 years old, and I'm over 20 years old. What do you know about me? If I tell you I'm between 50 and 60 years old and I'm over 20 years old, what do you know? Any thoughts? So if I tell you I'm between 50 and 60 and I'm over 20, what do you know about my age? I don't see y'all jumping in. It's not a trick question. Okay, I don't see you jumping in, but hopefully you know that if I tell you I'm between 50 and 60, and then I tell you I'm over 20, telling you I'm over 20 is redundant. It doesn't help you at all. Yeah, it just tells you you're between 50 and 60. So similarly, if you're between 138 and 139, and you're bigger than 138, you're just between 138 and 139. And then divided by, because that's how the formula works, the probability of X greater than 138. So we actually need to compute two probabilities between 138 and 139 first. So let's do that quickly. So the low is 138. The high is 139. And we don't know the probability, so I leave that blank. And hey, calculate. And I get 0.056. Good enough. and then divided by the probability of greater than 138. To be greater than 138, that means the low is 138. What's the high if you're greater than 138? Yeah, a zillion nines. And I want probability, so I leave that blank. Oh, wrong one, that one. And you get about 0.612. And that, if I just pop that into quick calculator, is about 9% chance. Any questions on this example? Okay. Next week, we're going to start seeing the true relevance of all this stuff. I mean, this is a fun little example, and it is actually important. But next week, we'll see why things are normally distributed, and then we'll use it all over the place. And not just next week, but for the rest of the entire term. So I'm going to stop my share. Going to stop my recording.